Hey tutorial heads, and welcome to How to CMake Good Part 1C. Last time in 1B we made a simple library, and today I'm going to go over how to divide a project into subdirectories. So I reopened the project that we used last time. I'm going to use GCC 7.3 to configure it. I'll configure with Ninja, and it'll still build and run exactly like we expect. In the project outline we have the executable and the library. I can run it. It says hello world, and we're going to divide this project up into subdirectories. So I want to put the library in a subdirectory. I'll call it say hello. To add a subdirectory, first we need a CMake lists.txt inside of it. And in the parent directory, we go to its CMake lists and we call add subdirectory on the name of the directory relative to this file. So the subdirectory is called say hello relative to this file, and it will include this CMake lists.txt. If we configure now, it still builds the same. It didn't change anything because the CMake lists in the subdirectory is empty. So I'll make a simple structure in here. I'll make a subdirectory called src for source rather, and a subdirectory called, let's call it say hello. I'll drag the files, move them into that directory. Now, well, if I configure, it'll yell because it can't find the source files. This add library cannot find these source files because I've moved them. So I have to move the add library call. I'll move it into the CMake lists for that directory. And since the paths relative to the CMake lists.txt have changed, I also have to change the paths to match the paths to the files. So relative to this CMake lists.txt is a subdirectory called source, then say hello, and then hello.hpp and cpp, and that's what you have to write in the source list for the library. I can compile it, well, I can configure it now, and I can kind of compile it. It successfully builds our library, but it won't compile the program. If we open up the main.cpp, it's trying to include this file, but the path to that file has changed now. So what we need to do, well, first I'm gonna move the program into its own subdirectory too. I'll make a subdirectory called, I'll call it hello.exe. And just like with the library, I'll add a CMake lists.txt to that directory. I'll move the main.cpp in there, and I'll snip this code out of the top CMake lists and put it in the subdirectory. Then I call add subdirectory on that subdirectory after we add the library subdirectory. Because this executable in this directory links to this library, we need to make sure that this library target is defined before CMake passes over this line. So in the top one, we add the library first, and then we add the executable. That order is very important. Otherwise, this wouldn't work the same way. I'll build it, but it'll have the same error because I've moved the main, but the include path is still different. So what I'll need to do, I need to define an include path for this library because at the moment there isn't one. The way you do that in CMake is with target include directories. You pass the name of the target, which is say hello, then the interface mode. In this case it will be public, and then a list of directories. I'll use CMake current source dir /src. So CMake current source dir will refer to the directory which owns the currently being processed CMake lists.txt. So that will refer to this say hello directory right here. This /source will of course refer to this subdirectory /src. Down here, Ninja has printed the command that used to compile the main.cpp, and we can see it didn't pass any include directories. If I compile again, I'll still get the error, but now this -i flag has appeared because what has happened is this target link libraries sees that I'm linking the library say hello, which is a target, into the executable. And the library has said, I have this public include directory called CMake current source dir /source. The public means that anyone that's consuming this library needs to also have this added to their include directories. So since the CMake good executable is consuming the library with a public include directory, it will also inherit the include directory of that library. And that's what's appeared here. It's a relative path to the build directory, but it is ... so up from the build directory into say hello, which is this directory, and down into source, which is this directory. So the include search path is right here. So our new include path that we include the hello.hpp needs to be relative to that. So source, say hello is the beginning, say hello / hello.cpp. And now our program compiles. It searched in the source directory, found the directory say hello, then found the subfile hello.hpp. Our new project outline shows the subdirectories. We can expand them and see the targets. I can right click, run the program, and it prints hello world just as it did before. So that's the very basics of setting up a project with multiple subdirectories. And the directory structure can be much more complicated or even simpler than this. But the main basis is you have to specify your include directories correctly and specify your links correctly. Now as a bonus, let's look into the library. I have this library defined, but say I want to give it a preprocessor definition. I'll say target compiled definitions, and just like include directories, I'll say hello public. I'll say hello version equals 4, just a random number there. This will set the preprocessor definition say hello version to 4. Now I'll go into hello.cpp. I'll change this string to be hello world from say hello version, and then say hello version, just like that. And our IntelliSense recognizes the preprocessor definition. I'll compile the library. If I run the program, it received the preprocessor definition that we set in the CMake lists.txt. Now since we've set it to public, this propagates to anyone who links to it. We'll go to the hello.exe, we'll go to main. I can say the say hello library is version say hello version. We'll compile the program and it'll print it twice. So this line comes from the library, this line comes from the executable. They both received the same say hello version. I can go to the library, just change that version, recompile everything, and it automatically updates. There we go. Something special happens. If I say public and I change it to private, our program will no longer compile because say hello version is not declared. Because I set it to private, this preprocessor definition stays only with the say hello library. It does not propagate to anyone who consumes it. This means that in this file, this is no longer defined, even though we linked to the library. There's a third mode called interface, and we're actually going to see the opposite happen. Now, in hello CPP, the say hello version is no longer present, but in main CPP it is, and our IntelliSense hover even says that it's defined. This is because interface has the opposite effect of private. It says that anyone who consumes this target receives these interface properties, but we ourselves do not. So public says both we and our consumers receive the value. Interface says only our consumers receive the value, and private says only we receive the value. Now if we go to hello.cpp, we can hover, it's defined, and in main CPP, it's defined to the same value. That's the very basics of using interface properties. They're an extremely powerful aspect of CMake, and we're going to be seeing a lot of them later on. So that's it for this video. Check the video description for any addenda, errata, more information, or important links. And until next time, keep CMaking good.